Today we're going to solve logarithmic equations and inequalities. So, if we have logs that are equal to each other with the same base, obviously what we're taking the log of has to be the same, so we can just set 4x minus 7 equal to x plus 5. Subtract x from both sides, add 7, divide by 3, and x is simply 4. This makes sense, because then we have the log of 9 equals the log of 9. Same thing over here, we can just set 7x minus 4 equal to 2x plus 11. We get 5x equals 15, divide by 5, x equals 3. Now if we don't have that situation, we can exponentiate both sides. So in order to do that, we look at what our base is. In this case, it's log base 4. So what we're going to do is we're going to make each side 4 to the power of that side. So 4 to the log base 4 of 5x minus 1 equals 4 cubed. Then we know by our properties that this cancels out, so we simply have 5x minus 1 equals 64. 5x equals 65. Divide by 5, x equals 13. Same thing over here, but this time our base is 2, so when we exponentiate, we're going to use a 2. So 2 to the log base 2 of x minus 6 equals 2 to the 5th. This cancels out. X minus 6 equals 32, and so x just equals 38. Now, when we have two different logs and another number, what we have to do is use our properties of logarithms in order to condense this into one log so that we can exponentiate it and solve. So remember, the product property says that if we have two logs added together with the same base, we can multiply those logs, what's inside those logs. So we have log of 5x times x minus 1 equals 2. So this is log of 5x squared minus 5x equals 2. Then once again we're going to exponentiate, so we're going to take 10 because log without a base is log base 10. This cancels out. We have 5x squared minus 5x equals 100. I'm going to divide both sides, divide everything by 5 and subtract my 100. So we have x squared minus x minus 20 equals 0. This factors into x minus 5 and x plus 4. So x equals 5 and negative 4. Now, it also says that we need to check for extraneous solutions. We know that we can't take the log of a negative number. So if using either of these x values in our original equation gives us the log of a negative number, that must be one of our extraneous solutions. So 5 is going to work. We'll have log of 25 plus log of 4. However, negative 4 gives us log of negative 20. So we know negative 4 is an extraneous solution, so x can only equal 5. Same thing over here, we're going to use our product property to condense. So we're going to have log base 4 of x times x plus 12 equals 3. So we're going to have log base 4 of x squared plus 12x equals 3. Exponentiate by raising each side with a base of 4. So we get x squared plus 12x equals 4 cubed, which is 64. X squared plus 12x minus 64 equals 0. And then we can factor this. X minus 4, x plus 16. So we get x equals 4 and negative 16. Once again, we have to check for extraneous solutions. 4 is going to work, negative 16 is not, so we just get x equals 4. Now, just real quick, we're going to also solve logarithmic inequalities in the same way we did logarithmic equations. So we're going to exponentiate. So we're going to take 10 log base 10 of x is less than or equal to 10 to the 4th. And so then we just get x is less than or equal to 10,000. Same thing over here, but first we want to simplify. So we have 2 natural log of x is greater than 5. We're going to add 1 to both sides. And we're going to divide by 2. So natural log of x is greater than 5 halves. We're going to exponentiate. Remember that natural log is log base e, so we're going to do e to the natural log of x is greater than e to the 5 halves. So x is greater than e to the 5 halves.